Okay, welcome to the final review. Okay, so let's go see what's going on. As you can probably imagine, we posted the final review things here. And so let's just go through as a reminder, let's just go through the rules. So it's just going to be the second half of the course, chapters 8 through 14. Obviously, you're doing this from home, so it's open book, open internet, open whatever. But again, like I cautioned you during the midterm, if you do the math, you got like 2 minutes and 47 seconds per question. So you really don't have the time to stop and go look things up in the book. Instead, you're gonna have to study and know this stuff. That's the only way to really make it through the exam. Okay, so there's 40 questions in a pool, so we're going to talk about all 40. But you're only going to get 25 out of that, and just like last time, I never know what order you're going to get them. Machine just randomly picks these things. And once again, the chapter and page number is to help you study. Yes, they do show up in the quiz, but that's mainly to show afterwards. You could say, well, what about that one? You could go back and look. But again, I'm not expecting you to go flip to page 540 to read about the finalized method. I'm not expecting that. Anyway, I do supplement a lot of material. That's why there's a no in a couple of the columns. And it's a timed quiz. You got an hour and 15 minutes. So let's just go through the list. Okay. So the static keyword. There's lots of things we use with the static keyword. One of the things we used was to basically say this piece of information, this one little field, is available to other instances. That's one of the things we could have done. The other is just a discussion in Chapter 8. We hadn't even seen, it's a contextual thing. In Chapter 8, the only thing we were using static for there was to talk about how, like the main class, whatever that thing is, like assignment 4, and then you have a main method, that thing is static. And so making that starting thing static has some side effects. And so I may be asking you about those. Okay. When passing an object, okay, not a primitive, but when passing an object to a method. So I want to pass an employee object to a method. What do I have to do to make that secure? That'd be a good question. And then aggregation and composition, if you recall, those are two separate terms, but they basically mean the same thing. It talks about having like an employee object inside a department object. That's it. It's nothing really fancy. Instead of just having, a field variable for integer, you have a field variable for employee. That's it. I mean, again, it's nothing magical. Input validation with objects. So let's say I've got an object like an employee class, and I'm passing that. How much input validation can I do? I mean, I could do one rather minor thing, but that's about it, right? I mean, there's hardly anything I could do. I really wasn't expecting you to try to decompose the object and check out each individual element. That's not really what secondary input validation is about. Constructor chaining. Now again, we're not talking about inheritance yet. So here we're just talking about I want one constructor to talk to another constructor. So how do you do that? And then enumerations. You guys probably remember that I really like doing enumerations. Can you remember why I like them? Rather than using an equivalent set of constants or something? The finalize method. The idea here is at the end of the life of a class, something occurs. And what would you typically do? Why would you even need a finalize method? That'd be a good question. And then Chapter 9. So character conversion. If you recall, you have to use the class version. Remember those wrapper class things? So I have to use character dot and then 2 upper or 2 lower or whatever, something like that. And do those guys do an in-place conversion? Is that how that works? Okay, so the next one is the index of method. When searching for strings, this one is pretty cool. But what's the return value? I mean, when it finds something, what does it return? When it doesn't find something, what does it return? Ooh, those are both good questions, aren't they? String builder. So, what's the magic associated with a string builder? How in the world is it capable of actually making it look like that strings are actually now mutable rather than immutable? How does it do that? The string builder methods. There's an awful lot of methods associated with the string builder, but one of the ones I think is rather strange that they should have but don't, and is available in other languages, is like the format thing. You know, we use string.format a lot, which it itself uses string builder, but that's not really the point. String builder doesn't have like a dot format. I think that's an oversight. By God, I think write my congressman and get them to fix that. But yeah, there's an awful lot of methods associated with string builder. You should probably know a little bit about them. Tokenizing. Tokenizing, like with the split command, breaks up a big string into an array of littler strings, right? So if the token was like a comma, does the comma appear in any of the array elements, or does it take them out? Ooh. Is there a way you can say, no, I want you to tokenize it, but leave the token in there? Okay. Well, the next one is a philosophical thing, like, what is the purpose for inheritance? I mean, this is kind of a simple kind of a question, really. It all talks about, okay, so I kind of understand the concept of object-oriented programming, but can you articulate why is inheritance such a good thing? What do we use it for? That's a good question. What's the point? Inheritance keywords. Okay, so you remember there's one for extends, there's one for super, and all those kinds of things. So be familiar with the keywords associated with doing inheritance. The next one is overriding methods. So whenever you have the same signature in a subclass as the signature on the superclass. So I have a kumquat method up here and a kumquat method down here. And so all you have to do is just have the same signatures, and the machine's going to say, well, I assume you need to override this thing. That's what you meant. The problem is that might actually be not what you intended. And so there's a directive you can use to tell the machine, no, this is not a coincidence. I fully intended to do this. I am fully aware that my kumquat down here matches the signature up there, and that's not an accident. Okay. So the protected keyword. A lot of you had problems with this before. So instead of just having public and private, we have public, private, and protected. And protected is me and all my children. That's the way I kind of remember it. Me and all my children, which I can see it and all my children can see it, but nobody else can. That's kind of the way I kind of get it. The object class. Now, the problem here is there's two different things called object. Sometimes when we use the word object with a little o, object means just any instance of a class, right? Because you've probably even heard me say an object is an instance of a class. But there's a capital O object, which is actually the name of a class called object. I know, it wouldn't have been so much easier if they would have come up with something better, called it like base object or something. But anyway, the object class. You need to know a little bit about the big O object class. Okay, the next one is yet another one of those philosophical ones. It's going to be like, okay, what's the purpose for polymorphism? I mean, again, I'm not asking you to describe the term or give me a definition. If you give me a definition, you're going to get 0 points. That's not what I'm asking. I'm specifically asking you to tell me, what is it for? What's the point? Can you describe the purpose behind this? So just like the one on the purpose for inheritance, these are philosophical discussions that you need to be able to convince me that you actually understand what it is we're doing. Okay. So the next one is interface. So we used a couple of interfaces. Hey, come back for the advanced Java class and we'll build some interfaces. But right now, we're just using interfaces. And what was the point for doing all that? I mean, why should we use an interface? What's the keyword that says I'm getting ready to adhere to this contract? You know, how does that work? Okay, chapter 11 on exceptions. If you recall, your program is just running along, and it hits an exception, and the sequence gets hijacked, and it immediately jumps directly to whatever has got the try block and the catch block. So once it goes to that location, there's not an easy way to get back to where you were. It completely hijacks the scenario, and whatever flow you had before is gone because you're someplace else now. So you need to kind of know a little bit about that. I talk about the built-in exception messages. One of the things I mentioned in class was that it'd probably be a good idea to both have your custom message plus the built-in message. Do you remember why? Why do you want to have two? One that you wrote and then one that the people who made Java wrote. You remember that? Okay. So the catch clause. If you recall how this thing works, is you can have multiple catch clauses, but you have to put them in a particular order because it's sort of like a filter. If you're trying to filter out, rocks, and you start with big hole in your first screen, and then smaller holes in your second screen, and little bitty holes in your last screen, it's not going to work, is it? Because everything's going to go through the big hole. But if you reverse the order and have small holes and then the medium size and big, your screen will work, right? I hope that analogy made sense. Same thing with the catch. If you put the most generic catch at the top, like just plain old exception, well then everything will go to there. But if you put, numeric exception or arithmetic exception or whatever the rest of the name of the exceptions are, then it will actually work the way you intended it to. The finally clause, what's it for? And when does it fire? Does it fire when there's a mistake? Does it fire when there's not a mistake? What do we use this thing for? Could you answer those questions? And then throwing exceptions. So around chapter 11, we changed the philosophy. We used to have, inside the employee class as an example, we used to have a print, a system.err.println, and then we would spit our error messages out. But when we got to chapter 11, we went through and took all those out and replaced them with exceptions. Why did we do that? What on earth for? Why are we now throwing exceptions? There's got to be a reason for it, other than just like a writing style. There's got to be some reason for doing it. So why, inside what I call the business logic layer, why do we throw exceptions? What's the point? Hey, have you figured out as a bunch of these, what is the point kind of a question? Yeah, okay, cool. Writing to a binary file, you might want to put an asterisk next to this one, because we didn't actually do this in like an assignment or anything. I mean, I talked about it in the lecture, but I'm going to ask you, like, what are the two components that are required? And I would not expect you to have that memorized. I'm just saying. So you might want to put an asterisk there saying, I want to look this one up before I take the exam. Okay, we're coming up on the 15-minute mark. You guys know how this works.